Anurag?
Yes, sir.
Sir,
Anurag,
about
your voice
band,
is not
sir,
audible.
about bandwidth and frequency
What?
graphs.
What? What?
Sir, about bandwidth. Last topic.
Okay, the bandwidth. Okay, we'll go to the Ayush.
Yes, sir. We then learned about
Ayush.
frequency and the composite waves.
Okay, composite signal and simple signal,
Frequency.
correct? And we had
Yes.
found what is the difference between a single signal and composite signal. Yes, Darshan. Screen is visible to all of you?
Yes, sir.
Okay. Again and
Yes,
again,
sir.
I'm asking the question because I want. Okay. So in the last lecture, we discussed about what is the difference between analog and digital. We also discussed about the periodic signal and the aperiodic signal. Can anyone tell what is the difference between analog and the digital signal? How you can able to differentiate both the things? Hello. How can able to differentiate both the things? Hello. How can able to differentiate analog signal and the digital signal?
Zero
Sir,
frequency.
analog signal is continuous while digital is discrete.
Digital is discrete. What do you mean by discrete? First of all, that at any particular of
Means it is
time,
not continuous.
if I can able to find the value of voltage or current or amplitude, that means the signal is analog or digital.
Sorry, sir.
Any particular of time, if I can able to measure its amplitude, voltage or current, that means that signal is analog or digital.
Sir, analog.
It's analog. Analog. And sir,
Wait from the PC. I'm going to establish the connection, but still the connectivity is low, so I'm trying. Don't leave the meeting. Just wait for 2 minutes. I'm going to the lab. Okay, now
I hope. Hello. Okay. Everyone can able to hear me?
Yes, sir.
I present a question in front of you. Just try to view the answer. I have one signal. There are a lot of options are given.
which is the correct option?
Periodic.
No, there are the multiple answers are possible. So I have one signal. Let us talk about the deterministic and random. What do you mean by the deterministic? At any particular of time, you can able to find the amplitude. It's called a deterministic. So the signal is first of all deterministic or random? It's a deterministic.
Yes, sir.
What about the C and D? What about the C and D? Which option is correct?
C.
Periodic.
Periodic or aperiodic?
Periodic.
Periodic.
Okay. Let's talk about the E and F. Is it continuous or discrete?
Continuous.
Okay.
Continuous.
And the G is nothing but it's analog signal.
Analog.
Again, there is one more question. One more question you have. Talk about this. There is a signal is given. What about option A or B? Which is the correct?
B. Random.
Okay. What about the C and D?
Periodic.
Okay, it's periodic. What about E and F? Continuous or discrete?
Discrete.
Discrete. And what about the analog and digital?
Digital.
It's a digital, but in the form of discrete. Okay. So when you combine all these samples together, it will become an analog. If you have a number of more samples, then because in the same signal, if you have a more number of samples, what happens that our samples are very much near to each other. That means here, if you put the 2 more samples or 3 more samples, what happens? You can easily able to track your analog signals. At any particular of time, you can able to get a voltage. That means you cannot able to take this digital. Okay. If the samples are far away, then you can able to say it's a digital form. But in the analog form, if the samples are very much near to each other, each and every particular of time, you can able to get the value. Remember that. So this you cannot able to confirm as analog and digital. That's why I put this example for you to make you understand. Okay. So this is a digital, but in the discrete form. This is a signal. But you cannot say it's a pure digital signal. Okay. What about this? This signal is a random. What about the periodic and aperiodic? It's a aperiodic signal.
Aperiodic.
What about the continuous and discrete?
Discrete.
It's a continuous. Where is the discrete?
Continuous.
It's a continuous signal. What about the analog and digital? It's an analog signal, not a digital. Okay. This was the thing I need to explain you. Now, the signal has been given. First of all, this is a digital signal. It's a continuous signal because at any particular time you can find the value. It's a periodic signal and it's a deterministic signal because you can able to identify which signals will come at after this cycle. Okay, so this was the just an signal. There is one screen in front of you, given the box signal. You have to find the frequency. Apply the concept what we had applied. On the x-axis, time is given in microsecond. On a y-axis, current is given. What should be the value of frequency? I need answer in megahertz. Your voice is not audible. Better you just write your answer on a chat box. Write your answer in a chat box. Your answer. You have this value 10, 15, 20, 25 microsecond. If I want to find a frequency for this particular of time, how can it be possible? .02 part? No. First of all, tell me what is the procedure you will apply?
0.1.
Here I can say the signal takes how many division? This is a 1 period, correct? How many division does it takes? It takes 2 division to complete the whole cycle. That means what is the value of a 1 division? It's a 5 microsecond.
5.
Correct? So what is the division for 2 division value time? It's a
10 microseconds.
10 microseconds.
10 microsecond. What is the relation between frequency and time?
1 upon 2.
1 by 3. 10 minutes. What is the value you will get?
0.1.
0.02 is the correct answer. What you'll get? The answer is, write it down, 0.01 megahertz. Ronak, one more zero you had added. The answer is 0.1 megahertz. Okay, so that was the answer, the 0.1 megahertz. Now, we was at last on discussion in the last lecture about the bandwidth. So bandwidth is nothing but you can able to find the difference between the highest frequency and the lowest frequency, and that we call as a bandwidth. So here the highest frequency is 5,000 and the lowest frequency is 10,000. If you subtract from high to low frequency, that 4,000 hertz is in the frequency. For this you had given the answer. The total bandwidth is 900 minus 100. It's 800 hertz. That is also that already we had discussed in the last lecture. Now, yes, where actually in the last lecture we had seen about this, we had stopped over here, a digital signal. Just I want to discuss about this thing. The band pass signal. Just mute yourself if you are not giving your answer. It's creating a noise in between. So the main important part over here to discuss about the band pass channel. Now, what do you mean by here the band pass channel? Let us take the first example where you will understand something. And an example I had given, if you want to send the data from a microcomputer to the telephone wire, see, whenever your internet broadband connections are also been transmitted from any channel, any one particular location station to the another location via using the fiber optics cable nowadays, before it is going to be transmitted the telephone lines. So you have the broadband transmission using modulations, is sending the computer data through a telephone subscriber line. The line connecting a residence to the central telephone office. That means whenever if you want to transmit the data from a computer to the telephone wire, now both have the different bandwidth. See, it's not like that you are sending the lots of data from a computer to the telephone wire. No, telephone wire has some capacity. So here for you, I just put an example. I have one telephone line, multiple telephone line. Each lines you can able to transmit the data which have a 120 hertz to the 1070 hertz. That is what the bandwidth I have. And you can able to send the signals for this particular signals only. What about the rest of the signals? That will be discarded. Okay, so that is what the importance of the band pass filter. See, the government have a certain rules that you cannot able to send for a voice. They have given the particular bandwidth. For Vodafone, Idea, Geo, all they have the different bandwidths. Okay, so depends upon that you are getting the speed of the connectivity. So this is nothing what we call a limited bandwidth. And if you want to send the data from a computer to the telephone line, again there is a problem over here, because the computer data can able to send the data in the digital form, but in the transmission line it can able to accept the data in terms of analog. So how these digital signals have been converted into analog, and that is what we call as a modem, and that is nothing but a modulation. Okay, we encode the data using the modem, and that is what modulators. Okay, so we need to convert the digital signal from a computer to analog signal and send the analog signals. We can install the two converter to change the digital to analog and vice versa. We require the two modems. Why? Because when you're sending the data from microcomputer transmission line, this modem is useful to convert into digital to analog. And again, from here to if you want to send the data to the computer, what actually required another modulation which converts into a analog to digital, and then you can able to receive from this microcomputer. Another example where we converts our analog to digital form. You know about the telephone cellular system. What you are doing when you speak something, you cannot able to send that analog signal directly through the telephone lines and can able to send the data from the larger distance. The reason is it can able to add the noise if you are sending directly analog signals. So what things you are doing? First things, what you will do, will convert your analog signals into a digitalized form using A to D converter. Then digital to analog to receiver side. But in between we are doing something on a data. That is what we call the DSP. That is the digital signal processing things we are doing. And why need it to do the digital signal processing? See, we have a limited bandwidth. So to have a limited bandwidth, we have to do something. That means I cannot able to convert each analog signal's values in the binary form, because it will contain a huge data stream of a binary numbers. So I have to minimize those binary streams, and that too, your data should not be lost. In that way, I need to minimize that. I need to encode, I need to do some process on a signal such that all the digital signals, when it reaches to the decoder side, digital to analog converter side, it must provide the same information what the sender had sent. એવું ના થાય કે પછી hello બોલું ને અહીંયા hi સંભળાય. No, it should not be like that. That's what the meaning. Now, this one is the question for you. A periodic signal has a bandwidth of 20 hertz. The highest frequency is 60 hertz. What will be the lowest frequency? Draw the spectrum if the signal contains all the frequencies of a same amplitude. All of you.
40 hertz.
40
Okay.
hertz, sir.
40 hertz. It's a 40 hertz. Okay. So spectrum, it will be like a series of a spike. Same spike will be there because the amplitudes are same. Okay, it's from 20 to 40. All the signals are same. So now the next topic in the signal characteristics, we have a transmission impartment. Okay. So while sending the data, what are the things comes in the picture when you send the analog signals? So there are the three terms which is very much important. We call it attenuation, distortion, and a noise. Now here, impartment passes due to these three terminology: attenuation, distortion, and noise. Everyone knows about the noise. Okay, fine. What is the difference between attenuation and the distortion? Anyone? What is the difference between attenuation and distortion? Okay, let us talk about first of all attenuation. What do you mean by the attenuation? What do you mean by attenuation?
Sir, it is the reduction of the amplitude of the signal.
Ayush, your voice is not clear.
Sir, it is the reduction of the amplitude of the signal.
Okay, distortion in the amplitude signals. Okay, let us discuss over here. Let's suppose I have the original signal. I am sending 1 to 0.3. But what happens in the 0.2 when the signal is transmitted through the transmission medium, through the wire or wireless? It might be anything to transmission medium. But when signal is transmitted from 0.1 to 0.2, look at this signal's amplitude. It reduces. Why? What is the reason to reduce? Because same analog signals cannot attain the same level when it transmits from one place to the longer distance. The reason is the power get reduces. When the power get reduces, the amplitude get reduces. And that's why the same amplitude signals we cannot able to receive on a 0.2. So what I need to do if I want to achieve the same original signals, I will add amplifier in between. So now 0.2 to 0.3, I had connected one amplifier. Now look at the original signals had been retrieved. Same example if I'll give. Whenever if you'll go home or nearby your area, wire ઉપર એક what do you call, એક suitcase જેવું disconnection ના wire ઉપર લટકાતું હશે. What we call for that? જોયું હોય તો ક્યારેક wire ઉપર એમ પેટી જેવું always હોય, like suitcase જેવું always there will be a tied on a wire, on a disconnection wires. What is the reason for that? What is that we call? We call as a repeater. And why we require the repeater? Why we require the repeater?
For extending connection.
For extending the connections. That means analog signals have a limited signal transmission. At particular point of only you will get the same amplitude. After that, we need to put the repeater to transmit, because આખી GTPL હોય તો GTPL મેઇન ઓફિસ એક જ હોય. પછી ત્યાંથી distribute થતો હોય. That means from there it distributes among the different centers. Okay, and from there to home to like different flats and everything. So we must require the repeaters over there. Same way here we use the amplifiers. Amplifier is nothing but another name of repeaters. So here, let's suppose how to find like what is the power attenuation. Attenuation always we calculate in terms of power. So suppose a signal is travels to the transmission medium and its power reduced by 1/2. That means P2 is equal to 1/2 the P1. Let's suppose the power P1 is 1. When it reaches to the power P2, P2 is nothing but a power at the receiver side. It's telling that when power is reduced to 1/2, so it's 1/2 10 P1. So this is how you can able to calculate, but the powers are always be calculated in the terms of dB. So to convert into dB, what we have, it's 10 log 10 P2 by P1. So what is the value? It's a 10 log 10, 0.5 by P1, P1 cancel, 0.5. It's a okay. It's a 0.3 dB. Okay. Are you getting or not? If you convert the power in terms of dB, this is how you can able to convert it. So it's a 0.3 dB. For you, the question is, if the signal travels to the amplifier, answer.
Sir, 10.
So 10
What is the
decibel.
answer for this?
So 10 decibel.
10?
10 decibel.
I need answer. 10 decibel. So 10, okay, 10 decibel, correct. Because the P1 log 10 raised to 10 is 1, so it's a 10 decibel. Fine. So this you can able to calculate. But sometimes the decibel is used measure in terms of millivolt, because the power unit is in millivolt. So in this case, it refers to the dB m, and it is calculate dB equal to 10 log 10 PM. That is a P2 by P1. So here the PM, the dBm is given as a minus 30. So PM, that is a 10. This log 10, if it go on this side, it's a 10 raised to minus 3, and that will give the millivolt. So calculate the power signal for the dB minus 30. This is how we can able to calculate. What about this? Solve for this. The loss in the cable is usually defined in the decibel per kilometer.
Sir, 10's power minus 0.15 into 2.
I need answer in millivolt. Yeah, asking for the 5 kilometer. Per kilometer dB is given.
Sir, 0.5.
Sir, 1.4.
Okay, answer is minus 1.5. Okay, so it's given, cable is given for per kilometer dB is 0.3 minus 0.3. So for 5 kilometers, it's 1.5 dB. Now, if you calculate the power, it's a 1.5. The answer is 1.4 millivolt. Everything is clear, all of you? Any doubt to measure the answer in a millivolt? Answer is clear, all of you? Okay, we'll move to the next. Now the terms, what do you mean when you call it distortion? You know about these signals. If you have the composite signal sent, that is the combination of multiple frequencies with the amplitude at the sender side, receiver side, if you are sending these signals, we are getting these signals. Now what happens to these all things? And that is what we call as a distortion. Okay, see, the signals is not getting attenuated, signals are getting correct. This is what the difference between attenuation and the distortion. Signals we are receiving, that is correct, but what happens at some particular time, at amplitude will get distorted. The noise will be added on a digital signals. Okay, this was the difference between distortion and attenuation. Now the noise. You know about the point one, when I transmit, due to the external noise is added due to the in a transmission line, the signal is shifted from one. Okay, this is what we call as a noise. Now, next is very much important. If I want to find what is the value of a noise in a signal. See, till now we had understood that, okay, this is how to calculate the power of a noise and everything. But if I want to find how many, what is the noise in a particular signal, and that is the definition we call as a signal to noise ratio. It always be indicated the signal, it's always the name it indicates is the ratio between the signal to noise. So if you want to find a signal to noise ratio in dB, it's a 10 log 10 S by N. So if I have the transmission channel which is noiseless, that means कोई पण signal, once a signal pass karo, you won't get any noise due to the transmission line. બીજો આવે તો બરોબર છે, પણ signal તો transmission line માંથી જ જાય. એના કારણે કઈ noise નહીં આવે. That's why we call it a noiseless channel. If there is no noise, what happens? It's a signal to power ratio that will be infinity. Ideally, it's not possible anytime. Okay, it should be infinity. Signal to noise ratio infinite જ હોવો જોઈએ. The reason is there should not be any noise, but ideally that is not possible. Okay, for a noiseless channel, the signal to noise ratio is always be infinity. So here I have the two figures, large SNR and a small SNR. How you differentiate these things? એવું કેમ કહેવાય large SNR? Because here noise ઓછો છે and small SNR માં noise વધારે છે. So what do you mean by large SNR and small SNR?
Sir, in SNR, the sound to noise ratio will be more, and in less SNR, the sound to noise ratio will be less.
Yeah, correct. What do you say? It depends upon the noise. Less noise, large SNR. Small noise, large noise, small SNR. Okay, they are inversely proportional. Now, I had given one question. The power of a signal is 10 millivolt and the power of the noise is 1 microvolt. What is the value of SNR and SNR dB? Answer, all of you.
10,000 ને 40.
What about SNR?
10 kilowatt.
I need answer in dB.
40.
Answer is 40. Just have a look in the answer what you said and answer is over here. Okay. Should I go to the next slide? Okay. The value of SNR and SNR dB for a noiseless channel.
Sir,
Infinite.
SNR is infinite. What about in dB?
Sir, infinite.
Okay, it's infinite because 10 log 10 infinite. Infinite into 10 is infinite. So we never achieve this ratio in real life. It's ideal. Okay, it's not possible. Now this, the new topic, the data rate limits, we'll discuss in the next lecture. Okay. Whenever you transmit the data, see, you always talk about the bits per second, kbps, mbps, gbps. Now, what do you mean by the bits per second? How you can able to achieve this total bandwidth? In this particular bandwidth, you can able to send this much of data rates. Okay. So next lectures, we are going to discuss about this thing, the data rates. We'll take that and then we can complete the lecture. Today, we'll start with Ayush, attendance, Ayush Parekh.
Yes,
Yes, sir.
Ayush Parekh.
Yes, sir.
Yeah, attendance.
Sir, IT 29.
Last. IT, last two numbers.
IT 29.
હું જેમને નામ બોલું ને
29.
ખાલી એટેન્ડન્સ બોલ લખતા જાજો. ચેટ બોક્સમાં લખતા જાજો. આયુષ પારેખ, attendance, write in the chat box.
Okay, sir.
Okay, IT 29. What about next? Anurag Panwar. Okay, line by line લખતા જાઓ ચલો બધા. Next. Ayush Jagani, Bansi, Darshan.
સર મારો ચેટ બોક્સમાં મેસેજ જ સેન્ડ નથી થતો.
Wait.
P130 ચેટ બોક્સમાં મેસેજ સેન્ડ નતા આવશે.
મારો નથી થતો.
Can attendance અલાવાઈ ગઈ છે? They can leave the meeting.
P130.
Write your attendance.
સર લખાઈ નથી ચેટ બોક્સમાં.
Rahul, your voice is not clear.
સર ફેલ ટુ સેન્ડ આવે છે.
અવાજ નથી થતો બેટા.
સર ફેલ ટુ સેન્ડ આવે છે.
મેસેજ સેન્ડ આવે સર.
દર્શન,
હા સર 130 C.
અવાજ કપાય છે બેટા, સંભળાતો નથી કાંઈ.
હેલો સર.
ફોન કરી દેજો ને બેટા. હા હોય તો
સર C130.
નથી clear, કેમ કે આમાં 3 જણા ઉમંગ બધાનો અવાજ સાથે આવે છે ને તો કંઈ સંભળાતું નથી. You just call me if you have a doubt.
સર પર્સનલમાં મેસેજ કરી દઉં.
દર્શન,
સર CE85.
CE80 સર.
85 sir.
leave the meeting all fine. 12 o'clock we'll meet in the lab session, all of you. Thank you.